Welcome to the video on Disentangling Architecture and Training for Optical Flow, a paper by Google Research. Since FlowNet, deep learning has led to rapid and considerable progress on optical flow, improving the endpoint error from over 8 to close to 2. In this progression, two models particularly stand out. PwCnet, published in 2018, was the first model to outperform classical optical flow techniques. Raft, published in 2020, provided a large improvement in flow quality. These two models heavily influenced those following it and acted as starting points for optical flow research. These two models have fairly different structures. PwCnet is inspired by classical optical flow. In contrast, Raft changes many of these elements. Raft's improved performance has been primarily attributed to these model differences. However, Raft also introduced a large number of differences in training based on recent advances in optimizers, learning rates, augmentations, and other improved training details. We attempt to directly understand the impact of a single improved modern training regime by applying it to three different models. We also perform a thorough ablation study on training details in the pre-training and fine-tuning stages. With this approach, we observe significant performance gains for both PwC and IRR, and a moderate performance gain for Raft. In fact, our Raft, with only modified training details, outperforms many of the recent state-of-the-art models. These improvements are even more surprising when each model's running time is taken into account. PwCnet is 5 times faster than Raft, but is only 8% worse on Kitty than Raft's original training. Our modern training scheme also improves Raft by nearly 15%, enabling it to outperform recent state-of-the-art papers like separable flow. On Cintel, we observe a similar trend. Again, our improved PwCnet is 5 times faster than Raft and only 13% worse. Our improved Raft is 10% better than the original and is a significant improvement on the Pareto frontier of time versus performance. These improvements can be easily seen in visualizations and often take the form of significantly better flow details. In this example, our improved PwCnet can recover the gap between the cart and the person in the back. Raft also benefits from the improved training and can better recover those same details. In addition, these improved models can often show surprising visual qualities, like PwCnet outperforming Raft on specific details like the space between the driver and the cart, and the improved Raft correctly capturing the very detailed flow on the back wheel. In addition to the improved performance, we perform a thorough ablation study on pre-training and fine-tuning. For the pre-training ablations, we iteratively build up our training scheme and report the gains on Cintel Final Validation Set. We show that many elements are important, including the dataset, gradient clipping, training schedules, and the number of training iterations. These gains total to nearly 45% improvement for IRR. In fact, simply changing the dataset can lead to large visual differences. Training PwCnet with autoflow can enable the network to recover, in the top row, the fine details between the skater's legs, and in the second row, coherent motion for the girl and dog. For fine-tuning, we observe that the train validation set used is important, as well as several details like the mixture of datasets. These differences again lead to improved ability to recover details. For example, in the second row, the very faint dragon indicated by the red arrow. We also show that in the right setting, for example 4K images, PwCnet and IRR can outperform Raft. In particular, PwC and IRR are both significantly faster and more memory efficient than Raft. As the size of the images increase, this benefit becomes larger. For example, both PwC and IRR can run on 4K images, while this leads to out-of-memory errors with Raft. Here is a visual example of our optical flow results on 4K images. In particular, please note the details on the jacket and the person's mouth. In summary, we focus on disentangling architecture and training, and find that, in addition to the model changes, the training techniques and dataset matter significantly. We also observe that there is currently no model to rule them all. Both PwCnet and IRR PwC are competitive with respect to other models and even offer large benefits like speed and memory efficiency. Thank you.